Hey there, HackerFrogs! This workshop is the third workshop for Intro to Web Exploitation. Let's take a few moments to review the concepts we learned in the previous workshop. Source code analysis is the process of analyzing the code of a piece of software with the goal of deeper understanding regarding its function. It is a common technique used in software security testing, but it requires the software source code be readily available. URL parameters are variables attached to the end of URLs. They are often used to send search queries to web servers, but they can be used to retrieve other data as well. Local file inclusion is a web app vulnerability where arbitrary local web server files can be accessed through a web interface. LFI vulnerabilities are typically identified when file names appear in URL parameters when accessing web pages. Operating system command injection is a web app vulnerability where arbitrary OS commands can be performed on the web server through a web interface. OS command injection can often lead to complete compromise of the web server, and if so, the server can be used as a foothold to attack other machines on the network. Let's move on to the topic of this workshop, the SQL Database Language. Structured Query Language is a programming language used for managing data held in relational databases. Simply put, SQL allows users to access and manage data contained in relational databases, which are common components in most web applications. As far as web exploitation is concerned, insecure implementation of SQL in web apps can lead to a very serious vulnerability called SQL injection. We will learn about SQL injection in a later workshop, but we should first learn how to use SQL in its intended manner before we learn how to abuse it. In a web browser, navigate to the following URL. On the web page, we are given a few details about the murder mystery we're going to use SQL skills to solve. First of all, the type of crime was murder. The time the murder occurred was January 15th, 2018, and the location where the murder took place was SQL City. Now that we know these details, let's take a step back and learn a few things about SQL. The largest unit in a SQL system is the database, which contain one or more tables. Tables themselves are made up of two types of elements: columns, whose names identify the type of data that should be entered into them, and rows, which contain data entries that correspond to the columns they fall under. The select command is the most common SQL command, which returns SQL entries depending on what additional parameters are provided. The from command specifies which table to retrieve data from. The SQL count function will return the number of entries in the specified column. Back in the web page, we see a section that describes what SQL queries are. Basically, queries are SQL commands that search the database for specific information. The SQL system then returns any matches that match the query parameters. We scroll down and see an example SQL query. When run, the select keyword will run the count function. The from keyword lets us specify a table to run the query on, and the target is the person table. We click the run button, which returns the number of rows in the person table. The limit filter restricts the number of entries returned to the number specified. The asterisk wildcard character can be used in the place of column names in a SQL query and represents all columns in a specified table. Back in the web page, we see the example query here, which will select all columns from the person table, but limit the results returned to a maximum of 10 rows. We click the Run button and see that the first 10 rows from the query are returned. The distinct clause will restrict the number of results returned by the query so that there will be no duplicate values. On the next example query, we see that the query here will return rows from the type column in the crime scene report table, but the distinct clause will ensure that no duplicate rows are returned. We click the Run button and see that there are 9 distinct entries in the table. If we did not include the distinct clause in the query, the system would have returned a lot of duplicate entries. The where filter is the most common SQL filter, and it restricts the results that are returned according to arguments given to it. Here, the results are restricted to rows where the name column has the text Kinsey Erickson. The equal operator is used with the where filter to return exact matches. If the contents of a row differ by even a single character, the match will not return. The AND clause is used with the where filter to further restrict the results returned, only returning rows that match both parameters on either side of the AND clause. This next query returns all columns from the person table, where the name entry is equal to Kinsey Erickson. And the query after that introduces the AND filter to further refine query results. When we run the query, we see that the results are restricted to theft as the type, and Chicago as the city. This next section asks us to retrieve the details regarding the murder mystery we're trying to solve. If we recall the details from earlier, the type of crime is murder. The city is SQL City. And we can even provide the date in the query, which is 2018, January 15. We see in the description column that there are 2 witnesses to the murder. One lives on the last house on Northwestern Drive, and the other witness, named Annabelle, lives on Franklin Avenue. The next section deals with partial matches and wildcard characters. The like operator is used with the percentage wildcard character to return partial matches. The percent symbol matches any characters on its respective side of the string. The next example query searches for distinct entries from the city column in the crime scene report table. The where filter is used with the like clause, with the percent wildcard after the letter I. This query will match any rows that start with the letter I. We run the query, and the expected rows are returned. We can reset the query, then give it a different string, %ing, which return all cities that end with ing. These 2 methods allow us to return partial matches that start with or end with specific strings. The next example query introduces the between and clause pairs, which allow results to be returned within a specific range. The SQL upper and lower functions are used to render output in all uppercase or lowercase letters, respectively. It can also be used in the where portion of a query to match results where the capitalization of a search term is unknown. In this example query, it will return distinct rows from the city column, and the where filter will return rows where the lowercase version of the string is SQL City. This is useful because the capitalization of this string could be a few different variations. The sum function is used to return the sum of all entries in a specified column. The AvG function is used to return the average value of all entries in a specified column. The max and min functions are used to return either the maximum or minimum values of a specified column, respectively. The order by keyword is used to return rows in ascending order, depending on the name of the column provided. The ASC and DESC keywords are used with the order by keyword to return rows in ascending or descending order, respectively. In the example query, we see that the max function can be used to retrieve the highest value for a particular column in a table. And the next example query shows that we can return rows in a specific order, either ascending or descending, by using the order by and ASC or DESC keywords. Based on the information we gathered from the crime scene report, we can search for the first witness, who is reported to live on Northwestern Drive, at the last house on that street. The person table includes the address number and address street name columns, so we can search that table. We want to return all of the columns from the person table. We use the where filter to specify that the address street name column should match Northwestern Drive. And we want to use the order by and DESC keywords to return only the highest number in the address number column. Using the limit keyword to restrict our query to only the first entry. When we run the query, we see that the first witness is named Morty Shapiro. For the second witness, we have a street name, Franklin Avenue, and name, Annabelle. Like the last query, we select all columns from the person table, but we use the where clause with the like keyword to partially match the name Annabelle. Then use the AND keyword to further restrict the matches to Franklin Avenue in the address street name column. When the query is run, we see that the name of the second witness is Annabelle Miller. Now that we have the names of the two witnesses, we can get more information by looking up their interview transcripts. But in order to do that, we'll need to learn how to join multiple tables into a single query. Join queries are queries that include information from more than one table. Here, we are selecting data from both the person table and the income table. To do so, the join clause must be used. When returned, the query incorporates search criteria from both the income and person tables. One important thing to notice is the ON clause, which provides the system with the columns which connect the tables involved. These connecting columns are called the primary key and foreign key. The columns are connected through the relational nature of SQL systems. Relational databases are databases where data in one table in the database can be connected to data in another table in the database. In this database, the GetFitNow check-in table and the GetFitNow member table are related through the membership ID and ID columns, respectively. In this relationship, the ID column is the primary key, and the membership ID column is the foreign key. Back at the web page, the next example query shows an example of a join query. After the select keyword, we see that the table names and column names are combined in the table name.column name format. After from and join, we input the tables involved. Then we use the ON clause with the primary and foreign key columns from each table in the table.column format. In this query, the where filter is applied to only return rows where the annual income is over $450,000. When run, we see that the query returns columns from both the person and income tables. In order to query the SQL system to retrieve the witness interviews, we'll need to connect the person and interview tables. We see that the interview table is connected to the person table through the person ID and ID columns, respectively. With this information, we can use a join query to retrieve the witness interviews. But there's one last thing we need to go over before we do that. The OR clause is another clause we can use with the where filter, and it returns entries if a match is found for either of the two conditions on either side of it. Following the join query example we saw before, we select the person.name and interview.transcript columns from the person table, then join the interview table. Next, we use the ON clause, where we provide the primary and foreign key columns. Lastly, we provide the filter, where we specify the names of the two witnesses, separated by an OR clause. When we run the query, the witness interviews are returned, and we receive a lot of clues to insert into our next queries. From Morty Shapiro, we receive the following clues. The suspect is a man. He is a member at the GetFitNow gym. His membership number starts with 48Z. He is a gold member at GetFitNow gym. His car license plate includes H42W. And from Annabelle Miller, we received these clues. The suspect was at the gym on January the 9th. If we look at the database diagram at the top of the web page, we can connect these clues with columns in relevant tables. From the GetFitNow check-in table, we will include the check-in date column. From the GetFitNow member table, we will include the ID and membership status columns. From the driver's license table, we will include the gender and plate number columns. Finally, from the person table, we want to return the name column. Since we're using a join query with the GetFitNow check-in, GetFitNow member, and driver's license tables, we need to find the primary and foreign key columns for these three tables. The check-in and member tables are connected by the membership ID and ID columns, respectively. The member and person tables are connected by the person ID and ID columns. And the person and driver's license tables are connected by the license ID and ID columns. This is going to be a very long query, but we'll break down parts of it as we go. We select person.name from the person table, then join the GetFitNow member table on the two key columns. Person.id and GetFitNow.personID. We then join the GetFitNow check-in table on GetFitNow check-in.membership ID and GetFitNowMember.id. Then join our last table, driver's license, on driver's license.id and person.licenseID. Next, we do the filter portion of the query. We use the lower function on the member.membership status because we don't know if the gold status in the column is capitalized or not. Next, we fill in the check-in date from the GetFitNow check-in table. And then we include a partial match for the plate number column from the driver's license table. We make sure to include percent signs on both sides of the string because we don't know where the string appears in the plate number. We can give the same treatment to the GetFitNow member ID number, only we know our search term is at the start of the string. When we run the query, we receive the name of our murder suspect, Jeremy Bowers. We can check our answer under the Check Your Solution box. And we see that our answer is correct. However, we see that there is one more challenge to solve before we wrap up this workshop. Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming. We can use the same query that we used to get the interview from the other two witnesses with Jeremy Bowers. And from the query results, we see the following clues about the identity of the mastermind. A woman. She has a lot of money. She is between 65 and 67 inches tall. She has red hair. She owns a Tesla Model S car. She attended the SQL Symphony concert 3 times in December 2017. So we can craft one last SQL query to identify the mastermind behind the crime. First, we need to identify which columns from which tables we need to include. We'll include the event name and date column from the Facebook event check-in table, and the height, hair color, gender, car make, and car model columns from the driver's license table. Lastly, we'll need the annual income column from the income table. To perform the query, we'll need to identify all of the connecting columns between these tables. The Facebook event check-in table's person ID column and the person table's ID column are connected. The driver's license table's ID column and the person table's license ID column are connected. And finally, the income table's SSN column and the person table's SSN column are connected. So with this information, we can craft the query that will reveal the mastermind. We want to return the person.name column from the person table, then join the 3 tables on the connecting columns. Then supply the search parameters for the event name column, the hair color column, the height column, the gender column, the car make column, and the car model column. From the results, we see that there is a single person that matches all of these criteria. So we copy the name, then plug it into the solution box at the bottom of the web page. We receive a congratulations message, and with that, we've finished the SQL Murder Mystery game. Let's review the SQL concepts we learned in this workshop. Structured Query Language is a programming language used for managing data held in relational databases. Relational databases are databases where data in one table in the database can be connected to data in another table in the database. The select command is common to all SQL queries looking to return specific info from the database. And the where filter allows very specific information to be returned by a query. In order for SQL queries to return information from more than one table, the join keyword must be used to connect all of the tables involved. In the next HackerFrogs AfterSchool web exploitation workshop, we'll learn about SQL injection vulnerabilities with the TryHackMe platform. Looking for more study material on this workshop's topics? See this video's description for links to supplemental documents and exercises. Until next time, HackerFrogs!